Question 1. Comparative studies suggest that organizations often face challenges in balancing the real-time analytical benefits of AWS Kinesis video streams with the need to maintain robust data security and comply with data governance mandates. When designing a solution that ingests and analyzes video feeds containing potentially sensitive information, which of the following risk assessment approaches best aligns with regulatory expectations for data protection and responsible data handling? Option A. Conduct a comprehensive risk assessment that identifies potential data privacy and security vulnerabilities specific to the video data being streamed, evaluates the likelihood and impact of these risks, and defines mitigation strategies aligned with relevant regulatory frameworks and AWS best practices for Kinesis video streams. Option B. Focus primarily on minimizing the operational costs associated with Kinesis video streams by selecting the most cost-effective configurations, even if it means forgoing certain security features or extensive data retention policies. Option C. Implement a reactive security model where security measures are only enhanced in response to identified security incidents or regulatory audit findings, rather than proactively assessing and mitigating risks. Option D. Prioritize the implementation of advanced real-time analytics features of Kinesis video streams, assuming that AWS's inherent security measures are sufficient to meet all regulatory compliance needs without further specific assessment. The correct answer is D. Prioritize the implementation of advanced real-time analytics features of Kinesis video streams, assuming that AWS's inherent security measures are sufficient to meet all regulatory compliance needs without further specific assessment. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between leveraging real-time video data for critical operational insights and the stringent regulatory requirements surrounding data privacy, security, and retention. Organizations operating in regulated industries, particularly those handling sensitive information, must balance the benefits of advanced analytics with the imperative to comply with applicable laws and guidelines. The need for robust risk assessment in the context of Kinesis video streams is paramount, as missteps can lead to significant legal penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach emphasizes a proactive and comprehensive risk assessment that integrates security, privacy, and compliance considerations from the outset. This involves identifying potential threats to data integrity and confidentiality, evaluating the likelihood and impact of these threats, and implementing appropriate mitigation strategies. For Kinesis video streams, this translates to understanding data access controls, encryption mechanisms in transit and at rest, data retention policies, and audit logging capabilities. Adhering to AWS best practices for Kinesis video streams, such as least privilege access, regular security reviews, and data lifecycle management, aligns with regulatory expectations for data protection and responsible data handling. This approach demonstrates a commitment to due diligence and a proactive stance on compliance, which is a hallmark of professional best practice in data analytics. Incorrect approach is analysis. An approach that solely focuses on the technical capabilities of Kinesis video streams without considering the regulatory landscape is professionally deficient. This overlooks the legal obligations to protect sensitive data, leading to potential violations of data privacy laws and industry-specific regulations. For instance, failing to implement appropriate access controls could result in unauthorized viewing of sensitive video feeds, a clear breach of privacy and security mandates. Another incorrect approach is to prioritize cost optimization over security and compliance. While efficiency is important, it should never come at the expense of regulatory adherence. Implementing inadequate security measures to save on AWS services, such as disabling encryption or using weak authentication, exposes the organization to significant risks and regulatory penalties. This demonstrates a lack of professional judgment and a failure to understand the potential consequences of noncompliance. Finally, an approach that relies on ad hoc security measures or reactive responses to incidents is also professionally unacceptable. Regulatory frameworks often require documented policies, regular audits, and a well-defined incident response plan. Neglecting these aspects means the organization is not prepared to handle data breaches or security incidents effectively, increasing the likelihood of severe regulatory repercussions and operational disruption. Professional reasoning. Professionals should adopt a risk-based approach to data analytics solutions, particularly when dealing with streaming video data. This involves a continuous cycle of identification, assessment, and mitigation of risks. Before deploying Kinesis video streams, a thorough understanding of the data being captured, its sensitivity, and the relevant regulatory requirements, e.g., HIPAA for healthcare, GDPR for personal data, or specific financial regulations, is essential. This understanding should inform the design of the solution, including data ingestion, storage, processing, and access controls. Regular reviews and updates to the risk assessment and mitigation strategies are crucial to adapt to evolving threats and regulatory changes. Question 2. Market research demonstrates that a leading financial analytics platform hosted on AWS is experiencing intermittent but significant performance degradation, impacting its ability to deliver real-time market insights to traders. The firm operates under strict financial regulations, requiring operational resilience and accurate data reporting. Given this context, which of the following approaches best addresses the performance challenges while adhering to professional and regulatory standards? Option A. Focus solely on optimizing individual SQL queries within the analytics dashboards without investigating the upstream data ingestion or downstream reporting processes. Option B. Conduct a comprehensive risk assessment to identify the most critical data pipelines and analytics workloads that, if underperforming, pose the greatest threat to business operations and regulatory compliance, and prioritize optimization efforts accordingly. Option C. Immediately implement aggressive query optimization techniques on all Amazon Redshift clusters and scale up all Amazon EMR clusters to their maximum capacity to ensure sufficient processing power. Option D. Defer all performance tuning activities until a critical system failure occurs, at which point a full incident response and remediation plan will be initiated. The correct answer is B. Conduct a comprehensive risk assessment to identify the most critical data pipelines and analytics workloads that, if underperforming, pose the greatest threat to business operations and regulatory compliance, and prioritize optimization efforts accordingly. Explanation. Scenario analysis. A financial services firm is experiencing significant performance degradation in its critical customer-facing analytics dashboard hosted on AWS. This degradation directly impacts the firm's ability to provide timely financial advice and execute trades, leading to potential reputational damage and regulatory scrutiny. The challenge lies in identifying the root cause of the performance issues within a complex AWS data analytics ecosystem, which includes services like Amazon Redshift, Amazon EMR, and Amazon Kinesis. The firm must balance the urgency of resolving the performance issues with the need to maintain data integrity, security, and compliance with financial regulations. The risk assessment approach is crucial here to prioritize remediation efforts based on their potential impact on business operations and regulatory adherence. Correct approach analysis. The correct approach involves a systematic risk assessment to identify and prioritize performance bottlenecks. This aligns with best professional practices in cloud data analytics, particularly within regulated industries like financial services. By first identifying the most critical data pipelines and analytics workloads that have the highest business impact and regulatory implications, the firm can focus its optimization efforts where they are most needed. This proactive and risk-informed strategy ensures that resources are allocated efficiently, minimizing the potential for financial losses or compliance breaches. For example, if a dashboard used for real-time fraud detection is underperforming, its resolution would be prioritized over a less critical reporting dashboard due to the immediate financial and regulatory risks associated with fraud. This approach directly supports the firm's responsibility to maintain operational resilience and data accuracy, as mandated by financial regulations. Incorrect approach is analysis. One incorrect approach is to immediately implement broad, unvalidated performance tuning techniques across all services without a clear understanding of the impact. This could lead to unintended consequences, such as increased costs, data corruption, or even further performance degradation in other areas. From a regulatory perspective, making significant changes to production systems without a proper risk assessment and testing plan can be seen as a failure to exercise due diligence, potentially violating principles of operational risk management and data governance. Another incorrect approach is to solely focus on optimizing individual components in isolation, such as tuning a single Amazon Redshift query, without considering the end-to-end data flow. This can lead to a whack-a-mole scenario where fixing one issue creates another downstream. Ethically and professionally, this demonstrates a lack of holistic system thinking and can result in wasted resources and prolonged downtime, impacting the firm's ability to meet its service level agreements and regulatory obligations. A third incorrect approach is to defer optimization efforts until a critical failure occurs. This reactive stance is inherently risky and unprofessional in a regulated environment. It suggests a failure to proactively manage operational risks and can lead to significant business disruption and potential regulatory penalties for noncompliance with operational resilience requirements. Professional reasoning. Professionals should adopt a structured, risk-based methodology for performance tuning. This involves 1. Understanding business and regulatory context. Identify critical workloads and their impact on business operations and compliance. 2. Monitoring and profiling. Utilize AWS monitoring tools, e.g., CloudWatch Performance Insights, to gather performance metrics and identify potential bottlenecks. 3. Root cause analysis. Systematically investigate identified bottlenecks, considering the entire data pipeline. 4. Prioritization. Rank optimization tasks based on their risk and impact, focusing on high-priority areas first. 5. Testing and validation. Implement changes in a controlled environment and thoroughly test before deploying to production. 6. Continuous improvement. Regularly review performance and adapt optimization strategies as the workload evolves. This systematic approach ensures that performance tuning is not only effective, but also aligns with the firm's risk management framework and regulatory responsibilities. Question 3. To address the challenge of enabling efficient data discovery and analysis while upholding stringent data privacy and compliance requirements, a data analytics team is designing a new data cataloging strategy. They need to decide how to manage metadata for a diverse range of datasets, some of which contain sensitive customer information. What is the most responsible and compliant approach for cataloging this metadata? Option A. Catalog all available metadata for every dataset without any initial classification of data sensitivity, assuming downstream security controls will manage access. Option B. Implement a tiered metadata strategy where data sensitivity is classified, and catalog entries include appropriate access controls, data masking recommendations, and compliance tags. Option C. Catalog all metadata, but rely solely on the assumption that users will exercise discretion and avoid accessing sensitive data based on dataset names. Option D. Exclude all metadata that could potentially be associated with sensitive data from the catalog to err on the side of caution, even if it limits discoverability. Correct answer is B. Implement a tiered metadata strategy where data sensitivity is classified, and catalog entries include appropriate access controls, data masking recommendations, and compliance tags. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between enabling data discovery and ensuring data privacy and compliance. The data analyst must balance the need for a comprehensive and searchable data catalog with the ethical and regulatory obligations to protect sensitive information. Mismanagement of metadata can lead to inadvertent data exposure, regulatory violations, and erosion of trust. Careful judgment is required to implement cataloging strategies that are both effective for analytics and robust in their privacy controls. Correct approach analysis. The correct approach represents best professional practice because it prioritizes data governance and compliance from the outset. By implementing a tiered metadata strategy that classifies data sensitivity and applies appropriate access controls and masking techniques at the catalog level, the organization adheres to principles of data minimization and purpose limitation. This proactive approach ensures that sensitive data is not unnecessarily exposed in the catalog, thereby complying with regulations that mandate the protection of personal and confidential information. It fosters a culture of responsible data handling and supports the principle of least privilege, which is a cornerstone of robust data security and privacy frameworks. Incorrect approaches analysis. One incorrect approach fails by broadly cataloging all metadata without considering data sensitivity. This creates a significant risk of exposing personally identifiable information, PI, or other confidential data within the catalog itself, violating privacy regulations and potentially leading to data breaches. It demonstrates a lack of due diligence in data governance. Another incorrect approach is to exclude all potentially sensitive metadata from the catalog. While seemingly protective, this approach severely hinders data discovery and usability, undermining the purpose of a data catalog. It can lead to duplicated efforts, missed analytical opportunities, and a general distrust in the data catalog's completeness, failing to meet the business's analytical needs and potentially violating guidelines that encourage data accessibility for legitimate business purposes when handled responsibly. A third incorrect approach involves relying solely on downstream access controls without cataloging sensitivity. This is a critical failure because the catalog itself becomes a vector for unauthorized access or accidental disclosure. If metadata indicating sensitivity is not present or is improperly managed within the catalog, users might unknowingly access or share sensitive data, leading to regulatory noncompliance and reputational damage. It neglects the fundamental principle of cataloging as a control point for data understanding and management. Professional reasoning. Professionals should adopt a data governance framework that integrates metadata management with privacy and security requirements. The decision-making process should involve 1. Data classification, clearly defining data sensitivity levels. 2. Policy development, establishing clear guidelines for cataloging and handling sensitive data. 3. Tooling and technology, selecting and configuring data cataloging tools that support granular metadata management, access control, and data masking. 4. Training and awareness, educating data stewards and analysts on data privacy, best practices, and the importance of accurate metadata. 5. Regular auditing, periodically reviewing catalog contents and access logs to ensure ongoing compliance and identify potential risks. Question 4. Compliance review shows that a data analytics team is integrating with several third-party APIs to enrich customer datasets. To expedite data ingestion, the team has proposed bypassing encryption for API calls between their internal analytics platform and the third-party services, arguing that the internal network is secure. Additionally, they have suggested implementing a generic, shared API key for all integrations to simplify management. The team has also not established a process for regularly auditing API access logs. Which of the following approaches best aligns with regulatory compliance and professional best practices for API integration in a data analytics context? Option A. Implement encryption for API data in transit. Use unique API keys for each integration, but do not log API interactions as it adds unnecessary overhead and is not explicitly mandated by all regulations. Option B. Encrypt data only when it is stored in the data lake. Use a single, shared API key for all integrations and conduct periodic ad hoc reviews of API access logs. Option C. Bypass encryption for API calls within the internal network to improve performance. Use a single, shared API key for all integrations and rely on network security alone to protect data. Option D. Implement robust encryption for all API data in transit and at rest. Utilize unique, securely managed credentials for each API integration, and establish a comprehensive logging and auditing framework for all API interactions. The correct answer is D. Implement robust encryption for all API data in transit and at rest. Utilize unique, securely managed credentials for each API integration, and establish a comprehensive logging and auditing framework for all API interactions. Explanation. Scenario analysis. This scenario presents a common challenge in data analytics, integrating external data sources via APIs while ensuring compliance with data privacy regulations. The professional challenge lies in balancing the need for timely and comprehensive data with the imperative to protect sensitive information and adhere to legal requirements. The complexity arises from the distributed nature of API integration, the potential for data leakage, and the need for robust security and access controls. Mismanagement can lead to significant regulatory penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves implementing a secure, auditable, and compliant API integration strategy. This includes encrypting data in transit and at rest, implementing strict access controls and authentication mechanisms for API endpoints, and ensuring that only necessary data is retrieved and processed. Furthermore, it necessitates maintaining detailed logs of all API interactions for auditing purposes and regularly reviewing these logs to detect any anomalies or unauthorized access. This aligns with the principles of data minimization, purpose limitation, and security by design, which are fundamental to data protection regulations like the General Data Protection Regulation, GDPR, if the jurisdiction were the EU, or the California Consumer Privacy Act, CCPA, if the jurisdiction were California, for the AWS Certified Data Analytics Specialty Exam, which is jurisdiction agnostic but often tested with a U.S.-centric lens. Adherence to principles found in U.S. federal and state privacy laws, e.g., HIPAA for health data, CCPA for consumer data, is paramount. This approach ensures that data is handled responsibly throughout its life cycle, from ingestion to processing. Incorrect approach is analysis, an approach that bypasses encryption for API calls, even for internal systems, is a significant regulatory and ethical failure. It exposes sensitive data to interception during transit, violating the principle of data security and potentially leading to data breaches. This directly contravenes requirements for protecting personal or confidential information mandated by various data protection laws. Another incorrect approach is to grant broad, unauthenticated access to API endpoints. This creates a severe security vulnerability, allowing unauthorized parties to access or manipulate data, leading to privacy violations and noncompliance with data access control mandates. It demonstrates a lack of due diligence in safeguarding data. Finally, failing to log API interactions or conduct regular audits of these logs is a critical oversight. Without proper logging and auditing, it becomes impossible to detect or investigate security incidents, track data access, or demonstrate compliance to regulators. This lack of transparency and accountability is a direct violation of audit trail requirements found in many regulatory frameworks. Professional reasoning. Professionals should adopt a risk-based approach to API integration. This involves identifying sensitive data, understanding the regulatory landscape applicable to that data, and designing integrations with security and compliance as primary considerations. A robust data governance framework, including clear policies on data handling, access control, and incident response, is essential. Regular training for personnel involved in data integration and analytics is also crucial to foster a culture of compliance. When in doubt, consulting with legal and compliance experts is a best practice to ensure all regulatory obligations are met. Question 5. Analysis of a machine learning model developed for credit risk scoring within a U.S.-based financial institution reveals that while it achieves high accuracy on the training dataset, its performance on a separate, more recent validation dataset shows a significant drop. The model development team proposes to proceed with deployment based on the strong in-sample performance, arguing that the validation dataset might be an anomaly. The validation team, however, recommends a more rigorous approach before deployment. Which of the following evaluation strategies best aligns with professional best practices and regulatory expectations for model validation in the U.S. financial sector? Option A. Allow the model development team to perform a self-assessment of the model's performance and limitations, as they have the deepest understanding of its internal workings. Option B. Rely primarily on the in-sample performance metrics, as they indicate the model's ability to learn from the training data, and dismiss the out-of-time validation results as potentially unrepresentative of future performance. Option C. Focus solely on optimizing a single, commonly cited performance metric, such as AUC, without considering other evaluation methods or the specific context of the model's application. Option D. Conduct out-of-time validation using a holdout dataset that spans a period after the training data, and supplement this with qualitative review of model assumptions, feature importance, and potential biases by an independent validation team. Correct answer is D. Conduct out-of-time validation using a holdout dataset that spans a period after the training data, and supplement this with qualitative review of model assumptions, feature importance, and potential biases by an independent validation team. Explanation. This scenario presents a professional challenge because it requires balancing the technical accuracy of model evaluation with the need to ensure that the evaluation process itself is robust, transparent, and defensible, especially in a regulated environment like financial services in the U.S. The core challenge lies in selecting an evaluation methodology that not only accurately reflects the model's performance, but also satisfies regulatory expectations for model risk management. The correct approach represents best professional practice because it employs a multifaceted evaluation strategy that includes both quantitative metrics and qualitative assessment. This aligns with U.S. regulatory guidance, such as that from the Office of the Comptroller of the Currency (OCC) and the Federal Reserve, which emphasize comprehensive model validation. Using a combination of holdout datasets for out-of-time validation and expert review of model assumptions and limitations provides a more complete picture of the model's reliability and generalizability. This approach ensures that the model performs well not only on historical data, but also in future, unseen scenarios, and that its underlying logic is sound and appropriate for its intended use. This thoroughness is crucial for demonstrating compliance with regulations that mandate robust model governance and risk mitigation. An incorrect approach that relies solely on in-sample performance metrics fails to address the risk of overfitting. This is a significant regulatory and ethical failure because it can lead to a false sense of confidence in a model that may perform poorly in production, potentially resulting in incorrect business decisions, financial losses, and non-compliance with regulations requiring models to be fit for purpose. Another incorrect approach that focuses only on a single, commonly used metric without considering its limitations or the specific context of the model's application is also problematic. This can lead to misinterpretations of model performance and a failure to identify critical weaknesses. Ethically, this represents a lack of due diligence. A third incorrect approach that bypasses independent validation in favor of developer self-assessment is a direct violation of model risk management principles and regulatory expectations for objectivity and independence in validation. This creates an inherent conflict of interest and undermines the integrity of the model validation process, posing a substantial regulatory risk. Professionals should adopt a decision-making process that prioritizes a holistic view of model evaluation. This involves understanding the model's intended use, the data it operates on, and the potential impact of its predictions. The process should include defining clear evaluation criteria that go beyond simple accuracy, incorporating robustness checks, sensitivity analyses, and qualitative assessments. Furthermore, it is essential to adhere to established model risk management frameworks and regulatory guidance, ensuring that validation is performed by qualified individuals who are independent of the model development team. Transparency in reporting evaluation results, including limitations and assumptions, is also paramount for building trust and ensuring accountability. Question 6. Compliance review shows that a data analytics team is using a large dataset containing customer information, including names, addresses, and purchase history, for developing predictive models. The current process involves restricting access to the dataset to a small group of analysts and occasionally removing direct identifiers like names. The review highlights concerns about the potential for re-identification and the adequacy of current data protection measures against evolving privacy regulations. What is the most appropriate course of action to ensure robust data governance and compliance? Option A. Implement advanced data masking techniques, such as tokenization or differential privacy, to pseudonymize or anonymize sensitive data elements while preserving analytical utility, and reinforce access controls with regular audits. Option B. Rely solely on strict access controls, ensuring only authorized personnel can access the raw dataset, and conduct periodic training on data handling best practices. Option C. Remove all personally identifiable information, PI, from the dataset and provide broader access to the anonymized dataset for faster model development. Option D. Apply a simple substitution cipher to mask sensitive fields, assuming this level of obfuscation is sufficient for compliance purposes. The correct answer is A. Implement advanced data masking techniques, such as tokenization or differential privacy, to pseudonymize or anonymize sensitive data elements while preserving analytical utility, and reinforce access controls with regular audits. Explanation. Scenario analysis. This scenario presents a common challenge in data analytics where the need to leverage data for business insights clashes with stringent data governance and compliance requirements. The professional must balance the utility of data with the imperative to protect sensitive information and adhere to regulations. The challenge lies in identifying the most appropriate method for data masking or anonymization that satisfies both business needs and regulatory mandates, without compromising the integrity or confidentiality of the data. The risk of noncompliance, including potential fines and reputational damage, necessitates a thorough understanding of applicable regulations and best practices. Correct approach analysis. The correct approach involves implementing robust data masking techniques that pseudonymize or anonymize sensitive data elements while preserving the analytical utility of the dataset. This aligns with the principles of data minimization and purpose limitation, which are fundamental to data protection regulations such as the General Data Protection Regulation, GDPR, or the California Consumer Privacy Act, CCPA, depending on the jurisdiction specified for the exam. By using techniques like tokenization, generalization, or differential privacy, the organization can reduce the risk of re-identification while still enabling meaningful analysis. This approach demonstrates a commitment to privacy by design and by default, ensuring that data is handled responsibly throughout its lifecycle. Incorrect approach is analysis. One incorrect approach is to simply remove all personally identifiable information, PI, without considering the potential for re-identification through data linkage. This can be insufficient if the remaining data, when combined with external sources, can still identify individuals. This failure to adequately protect data privacy violates the spirit and letter of data protection laws, which require not just the removal of direct identifiers, but also measures to prevent indirect identification. Another incorrect approach is to rely solely on access controls without implementing data transformation or anonymization. While access controls are crucial, they do not inherently protect the data itself if it is compromised or if authorized users misuse it. This approach fails to address the inherent risks associated with handling sensitive data and can lead to breaches of confidentiality, a direct violation of regulatory requirements. A third incorrect approach is to use a superficial masking technique that does not adequately obscure the underlying sensitive data, such as simple substitution with generic values that are easily reversible or predictable. This approach creates a false sense of security and leaves the organization vulnerable to privacy violations and regulatory penalties. It demonstrates a lack of due diligence in understanding the effectiveness of the chosen masking method. Professional reasoning. Professionals should approach such scenarios by first identifying the specific regulatory framework applicable to the data being handled. This involves understanding the definitions of sensitive data, PI, and the requirements for data protection and privacy. The next step is to assess the analytical requirements for the data and determine what level of detail is truly necessary for the intended insights. Based on this assessment, professionals should research and evaluate various data masking and anonymization techniques, considering their effectiveness in protecting privacy while maintaining analytical utility. Implementing a layered security approach that combines appropriate data transformation with robust access controls and ongoing monitoring is best practice. Regular audits and reviews of data handling processes are essential to ensure continued compliance and adapt to evolving threats and regulations. Question 7. Consider a scenario where a data analytics team is evaluating a new AWS service for processing sensitive customer data. The team is under pressure to deliver new analytical features quickly to meet business demands. They have identified a new AWS service that appears to offer significant performance improvements and cost efficiencies for their specific use case. What is the most appropriate decision-making approach to ensure compliance with the AWS well-architected framework and relevant data governance principles? Option A. Deploy the new AWS service immediately to leverage its performance benefits and address business demands, assuming AWS has already secured the underlying infrastructure. Option B. Prioritize the cost savings offered by the new AWS service and proceed with adoption, deferring any detailed security or compliance reviews until after the initial deployment. Option C. Rely exclusively on the default security configurations provided by AWS for the new service, as these are generally considered sufficient for most use cases. Option D. Conduct a comprehensive security and compliance review of the new AWS service, including an assessment of its alignment with the security and reliability pillars of the AWS well-architected framework, and implement necessary configurations and controls before migrating sensitive data. The correct answer is D. Conduct a comprehensive security and compliance review of the new AWS service, including an assessment of its alignment with the security and reliability pillars of the AWS well-architected framework, and implement necessary configurations and controls before migrating sensitive data. Explanation: this scenario presents a common challenge in cloud data analytics, balancing the need for rapid innovation and feature delivery with the imperative to maintain robust security and compliance. The professional challenge lies in making a decision that optimizes for both business agility and adherence to the AWS well-architected framework's principles, specifically the security and reliability pillars, which are paramount in regulated environments. The chosen approach must demonstrate a proactive understanding of potential risks and a commitment to mitigating them through established best practices. The correct approach represents best professional practice because it prioritizes a thorough risk assessment and the implementation of appropriate security controls before deploying sensitive data into a new service. This aligns directly with the security pillar of the AWS well-architected framework, which emphasizes protecting data and systems. It also supports the reliability pillar by ensuring that the chosen solution is resilient and can handle potential security incidents without compromising data integrity or availability. Furthermore, in the context of U.S. regulations governing data privacy and security, such as HIPAA for healthcare data or PCI DSS for payment card information, though not explicitly stated, the principles are universally applicable to regulated data. A proactive security posture is a fundamental requirement. Failing to conduct due diligence on security implications before adoption can lead to regulatory noncompliance, data breaches, and significant financial and reputational damage. An incorrect approach that involves deploying the service immediately without a security review is professionally unacceptable because it represents a reckless disregard for data protection and regulatory obligations. This directly violates the security pillar's guidance on implementing security best practices and could lead to severe penalties under U.S. data protection laws, which mandate reasonable security measures. Another incorrect approach, focusing solely on cost optimization without considering security implications, is also flawed. While cost is a factor, it should never supersede security and compliance requirements, especially when dealing with sensitive data. This approach demonstrates a lack of understanding of the potential long-term costs associated with security breaches and regulatory fines, which far outweigh short-term savings. A third incorrect approach, relying solely on the cloud provider's default security settings without customization or validation, is insufficient. While AWS provides robust security features, they are often configurable and require specific implementation to meet the unique security needs and regulatory requirements of an organization. Assuming default settings are adequate is a common pitfall that can lead to security gaps. Professionals should employ a decision-making framework that integrates risk management and compliance into the technology adoption lifecycle. This involves 1. Identifying the data sensitivity and regulatory requirements. 2. Evaluating potential services against the AWS well-architected framework pillars with a strong emphasis on security and reliability. 3. Conducting a thorough risk assessment for each service, considering potential threats and vulnerabilities. 4. Implementing necessary security controls and configurations based on the risk assessment. 5. Documenting the decision-making process and the rationale for the chosen approach. This systematic approach ensures that business objectives are met without compromising security, compliance, or operational integrity. Question 8. The investigation demonstrates that a data analytics team is experiencing escalating costs associated with their Amazon EMR cluster, which processes large volumes of clickstream data for real-time analytics. While cost reduction is a primary objective, maintaining low query latency for critical dashboards is non-negotiable. The team is considering several strategies to address this situation. Option A. Conduct a thorough performance profiling of the EMR cluster to identify specific resource bottlenecks and query inefficiencies. Then implement targeted optimizations such as right-sizing EMR instances, optimizing Spark configurations, and improving data partitioning strategies based on the profiling results. Option B. Implement aggressive data compression techniques across all datasets without first assessing their impact on read/write performance and the computational overhead of decompression during query execution. Option C. Migrate the entire clickstream data processing workload to a less expensive, on-premises infrastructure without a comprehensive cost-benefit analysis or performance benchmarking against the current AWS environment. Option D. Immediately reduce the number of EMR instances and scale down the instance types to the smallest available configurations to achieve maximum cost savings, assuming that any performance degradation will be acceptable. The correct answer is A. Conduct a thorough performance profiling of the EMR cluster to identify specific resource bottlenecks and query inefficiencies. Then implement targeted optimizations such as right-sizing EMR instances, optimizing Spark configurations, and improving data partitioning strategies based on the profiling results. Explanation. This scenario presents a professional challenge due to the inherent trade-offs between cost optimization and performance in cloud-based data analytics. Organizations must balance the need to control expenditure with the imperative to deliver timely and accurate insights, especially when dealing with sensitive data or time-critical business operations. The AWS Certified Data Analytics Specialty Exam emphasizes understanding how to architect and manage data solutions that are both cost-effective and performant, adhering to best practices, and, where applicable, regulatory considerations for data handling and processing. The correct approach represents best professional practice because it prioritizes a holistic understanding of the workload's performance characteristics and cost drivers before implementing changes. This involves detailed monitoring, profiling, and benchmarking to identify specific bottlenecks or inefficiencies. By leveraging AWS Cost Explorer and Cloud Watch metrics, a data professional can gain granular insights into resource utilization, query performance, and data transfer costs. This data-driven approach allows for targeted optimizations, such as right-sizing instances, optimizing data partitioning and indexing strategies, or choosing appropriate storage tiers, all of which directly impact performance efficiency without compromising data integrity or compliance. This aligns with the AWS Well-Architected Framework's performance efficiency pillar, which advocates for designing systems that can efficiently meet user demand and scale to handle increases in load. An incorrect approach that focuses solely on reducing costs by indiscriminately scaling down resources without understanding the performance impact is professionally unacceptable. This could lead to degraded query response times, increased data processing latency, and potential service disruptions, directly impacting business operations and user satisfaction. From a regulatory perspective, if the data being processed is subject to specific service level agreements, SLAs, or compliance requirements, e.g., related to data availability or processing timelines, such a reduction in performance could constitute a breach of those obligations, leading to fines or reputational damage. Another incorrect approach that involves implementing performance optimizations without proper testing and validation is also professionally unsound. This can introduce new, unforeseen performance issues or even data corruption. Without a controlled testing environment and rollback strategy, such changes pose a significant risk to the stability and reliability of the data analytics platform. This lack of due diligence can lead to operational failures and a loss of trust in the data analytics capabilities of the organization. The professional decision-making process for similar situations should involve a structured, iterative approach. First, clearly define the performance objectives and any associated cost constraints. Second, establish baseline performance metrics through comprehensive monitoring and profiling. Third, identify potential areas for optimization based on the collected data. Fourth, design and implement targeted changes in a controlled manner, ideally in a staging environment, with thorough testing and validation. Fifth, monitor the impact of these changes on both performance and cost in the production environment. Finally, document all changes and their outcomes for future reference and continuous improvement. This systematic process ensures that optimizations are effective, risk is managed, and business objectives are met. Question 9. Upon reviewing the operational health of a critical data analytics pipeline on AWS, which strategy for monitoring and alerting would best optimize process efficiency while ensuring timely detection of significant issues and adherence to data integrity principles? Option A. Configure alerts for every minor fluctuation in performance metrics, regardless of its immediate impact on the overall data pipeline's integrity. Option B. Establish a single, high-severity alert threshold that triggers only when a major component experiences a complete failure. Option C. Implement a tiered alerting system that categorizes alerts based on the severity of the potential impact on data quality and pipeline availability, with distinct notification channels for each tier. Option D. Disable all alerts for components deemed non-critical to reduce the volume of notifications. The correct answer is C. Implement a tiered alerting system that categorizes alerts based on the severity of the potential impact on data quality and pipeline availability, with distinct notification channels for each tier. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing the need for real-time operational visibility with the potential for alert fatigue and the cost implications of extensive monitoring. In the context of AWS Certified Data Analytics Specialty, ensuring data pipelines are robust, performant, and compliant is paramount. The challenge lies in designing a monitoring strategy that is both effective in detecting critical issues and efficient in resource utilization, while also adhering to any implicit or explicit regulatory requirements for data integrity and availability. Correct approach analysis. The correct approach focuses on implementing a tiered alerting strategy based on the criticality of the data pipeline component and the potential impact of its failure. This involves defining clear thresholds for different levels of alerts, e.g., informational, warning, critical, and ensuring that alerts are actionable and routed to the appropriate teams. For data analytics workloads on AWS, this aligns with best practices for operational excellence and reliability, as outlined in the AWS well-architected framework. Specifically, it supports the reliability pillar by enabling proactive detection and rapid response to failures, and the cost optimization pillar by avoiding unnecessary alerts and resource consumption. From a regulatory perspective, this approach supports data integrity and availability by ensuring that issues are identified and addressed promptly, minimizing data loss or downtime, which can be critical for compliance in many industries. Incorrect approaches analysis. Alerting on every minor deviation or anomaly, regardless of its impact, leads to alert fatigue. This is professionally unacceptable because it diminishes the effectiveness of the monitoring system, causing critical alerts to be overlooked. Ethically and regulatorily, this can lead to a failure to detect and respond to significant data integrity or availability issues, potentially violating data protection regulations or industry-specific compliance mandates that require timely incident response and data assurance. Implementing a single, high-threshold alert for all pipeline components is also professionally flawed. This approach is too coarse-grained and fails to differentiate between minor performance degradations and critical failures. It risks missing subtle but important issues that could impact data quality or lead to eventual failure. From a regulatory standpoint, this lack of granular monitoring can result in non-compliance with requirements for maintaining data accuracy and availability, as subtle data corruption or performance bottlenecks might go undetected. Disabling alerts for non-critical components entirely, even if they are part of a larger data pipeline, is a significant ethical and regulatory failure. While it reduces alert volume, it creates blind spots. If a non-critical component fails, it could cascade and impact downstream critical processes or data integrity. This directly contravenes the principle of comprehensive data governance and assurance, which is often a regulatory requirement. It demonstrates a lack of due diligence in ensuring the end-to-end health of the data analytics system. Professional reasoning. Professionals should adopt a risk-based approach to monitoring and alerting. This involves understanding the business impact of each component's failure, defining clear service level objectives, slow and service level indicators, SLI, and mapping these to specific alert thresholds. The decision-making process should prioritize alerts that directly impact data integrity, availability, or security. Regular review and tuning of alert thresholds and notification strategies are essential to maintain effectiveness and prevent alert fatigue. Professionals must also consider the specific regulatory landscape governing their data and industry to ensure their monitoring strategy meets all compliance obligations. Question 10. Risk assessment procedures indicate that a financial services firm is leveraging AWS Lambda and Amazon S3 to build a serverless data analytics pipeline for processing customer transaction data. This data includes personally identifiable information, PI, and sensitive financial details. The primary objective is to identify fraudulent transaction patterns. Given the regulatory environment governing financial data, what is the most appropriate approach to ensure data security and compliance within this serverless architecture? Option A. Process raw customer transaction data directly in AWS Lambda without any form of anonymization or pseudonymization, as the focus is solely on fraud detection and not on individual customer profiling. Option B. Rely on the default security configurations of AWS Lambda and Amazon S3, assuming that AWS provides sufficient protection for all data processed within its services. Option C. Grant broad read and write access to the S3 buckets containing customer data to all team members involved in the analytics project to facilitate collaboration and speed up development. Option D. Implement robust encryption for data at rest and in transit. Enforce granular IAM policies based on the principle of least privilege, and establish comprehensive logging and auditing for all data access and processing activities. The correct answer is D. Implement robust encryption for data at rest and in transit. Enforce granular IAM policies based on the principle of least privilege, and establish comprehensive logging and auditing for all data access and processing activities. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between leveraging advanced serverless analytics capabilities for business insights and the imperative to protect sensitive customer data. The ethical dilemma arises from the potential for unintended data exposure or misuse when processing large volumes of personal information in a distributed, cloud-native environment. Professionals must balance the benefits of agile, scalable analytics with robust data governance and security practices, ensuring compliance with relevant regulations. Correct approach analysis. The correct approach involves implementing a multi-layered security strategy that incorporates data encryption at rest and in transit, strict access controls using IAM policies, and regular security audits. This aligns with best practices for serverless data analytics, emphasizing a security by design philosophy. Specifically, it adheres to the principles of data minimization and purpose limitation, ensuring that data is only accessed and processed for legitimate business purposes. Furthermore, it supports the principle of accountability by maintaining audit trails of data access and processing activities, which is crucial for regulatory compliance and incident response. This approach proactively mitigates risks by embedding security into the architecture from the outset. Incorrect approaches analysis. One incorrect approach is to rely solely on the default security settings of serverless services without implementing custom security measures. This fails to address the specific risks associated with sensitive data and can lead to regulatory violations if data breaches occur. Demonstrates a lack of due diligence and a disregard for the principle of adequate security measures. Another incorrect approach is to grant broad access permissions to all users involved in the analytics process, assuming that trust is sufficient. This violates the principle of least privilege, a fundamental security tenet, and significantly increases the risk of unauthorized access or data misuse. It also fails to establish clear accountability for data handling. A third incorrect approach is to process sensitive data without anonymization or pseudonymization techniques where feasible. This directly contravenes data protection regulations that mandate the protection of personal data and may lead to severe penalties if such data is compromised. It shows a failure to implement appropriate technical and organizational measures to safeguard data subjects' rights. Professional reasoning. Professionals should adopt a risk-based approach to serverless data analytics. This involves identifying sensitive data, understanding its life cycle, and assessing potential threats and vulnerabilities. Decision-making should prioritize data protection and compliance by implementing robust security controls, adhering to the principle of least privilege, and regularly reviewing and updating security measures. Continuous monitoring and auditing are essential to detect and respond to potential security incidents promptly. A proactive and security-conscious mindset is paramount when working with serverless technologies and sensitive data. Question 11. Governance review demonstrates that the organization is seeking to enhance its fraud detection capabilities using advanced analytics on customer transaction data. The primary objective is to identify anomalous patterns indicative of fraudulent activity. However, the review also highlights the critical need to comply with U.S. data privacy regulations, which approach best balances the need for effective fraud detection with regulatory compliance. Option A. Implement a fraud detection system that directly analyzes raw, personally identifiable customer transaction data, relying solely on access controls for protection. Option B. Collect all available customer transaction data and associated metadata, processing it through a fraud detection model without specific justification for each data element's inclusion. Option C. Halt all advanced analytics initiatives for fraud detection until a comprehensive, organization-wide data privacy framework is fully established and audited. Option D. Develop and deploy an anomaly detection model that operates on anonymized or pseudonymized transaction data, ensuring that only aggregated or de-identified information is used for analysis. The correct answer is A. Implement a fraud detection system that directly analyzes raw, personally identifiable customer transaction data, relying solely on access controls for protection. Explanation: scenario analysis. This scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for fraud detection and adhering to stringent data privacy regulations. The need to process sensitive customer data for anomaly detection requires a delicate balance, where the pursuit of security objectives must not compromise legal and ethical obligations. Careful judgment is required to ensure that the chosen analytical approach is both effective in identifying fraudulent activities and compliant with the specified regulatory framework. Correct approach analysis. The correct approach represents best professional practice because it prioritizes data minimization and anonymization techniques before applying analytical models. This aligns directly with the principles of data protection and privacy embedded within U.S. regulations, such as the principles of data minimization and purpose limitation, often found in state-level privacy laws and industry-specific regulations. By processing only the necessary data and transforming it to obscure individual identities, the organization reduces the risk of unauthorized access or misuse of sensitive information, thereby upholding its legal and ethical responsibilities. This proactive approach demonstrates a commitment to responsible data handling and risk mitigation. Incorrect approaches analysis. One incorrect approach fails to adequately address data privacy by directly analyzing raw, personally identifiable information, PI, without sufficient anonymization or pseudonymization. This poses a significant regulatory risk, as it likely violates data protection principles requiring data to be processed in a manner that ensures appropriate security, including protection against unauthorized or unlawful processing and against accidental loss, destruction, or damage. Such a failure could lead to substantial fines, reputational damage, and loss of customer trust. Another incorrect approach is to forego advanced analytical techniques altogether due to perceived regulatory complexity. This is professionally unacceptable because it neglects the organization's duty to protect its customers and assets from fraud. While regulatory compliance is paramount, it should not be an excuse for inaction when effective, compliant solutions exist. This approach demonstrates a lack of proactive problem-solving and a failure to balance security needs with regulatory requirements. A third incorrect approach involves implementing a fraud detection system that relies on broad data collection without a clear, documented purpose for each data element. This violates the principle of purpose limitation, which mandates that data should be collected for specified, explicit, and legitimate purposes, and not further processed in a manner that is incompatible with those purposes. Without a defined purpose for every piece of data ingested, the system risks collecting and retaining information unnecessarily, increasing the potential for privacy breaches and noncompliance. Professional reasoning. Professionals should adopt a risk-based approach, starting with a thorough understanding of the applicable U.S. regulatory landscape, e.g., state privacy laws, industry-specific regulations like HIPAA if applicable, and general principles of data protection. This involves identifying sensitive data, assessing the risks associated with its processing for fraud detection, and then selecting analytical techniques that can achieve the desired outcome while adhering to data minimization, purpose limitation, and robust security measures. Collaboration with legal and compliance teams is crucial to ensure that all implemented solutions meet regulatory standards. The decision-making process should prioritize transparency, accountability, and the protection of individual privacy throughout the data lifecycle. Question 12. Performance analysis shows a significant increase in unusual transaction patterns within the financial services platform, potentially indicating fraudulent activity or operational anomalies. The data is stored in Amazon TimeStream, and the team needs to implement a solution to detect these anomalies in near real time while adhering to strict U.S. financial regulations. Which approach best balances detection accuracy, regulatory compliance, and operational efficiency? Option A. Store all transaction data in a standard relational database and perform batch analysis for anomalies on a weekly basis, focusing solely on identifying large deviations from the average transaction amount. Option B. Implement a simple threshold-based alerting system that flags any transaction exceeding a predefined monetary value, relying on manual review of all flagged transactions by the operations team. Option C. Develop a custom anomaly detection model using Amazon SageMaker, incorporating time series forecasting techniques and integrating alerts with AWS Lambda for immediate notification to a dedicated fraud investigation team, ensuring all data handling adheres to GLBA and BSA requirements. Option D. Utilize a generic, off-the-shelf anomaly detection tool that requires minimal configuration, assuming it will cover all potential financial irregularities without specific validation against U.S. financial regulations. The correct answer is C. Develop a custom anomaly detection model using Amazon SageMaker, incorporating time series forecasting techniques and integrating alerts with AWS Lambda for immediate notification to a dedicated fraud investigation team, ensuring all data handling adheres to GLBA and BSA requirements. Explanation: Scenario analysis. This scenario presents a common challenge in data analytics, identifying and addressing anomalies in time series data that could indicate fraudulent activity or operational issues. The professional challenge lies in distinguishing genuine, albeit unusual, patterns from those that require immediate investigation, while also adhering to strict data privacy and security regulations. The need for speed in detection must be balanced against the risk of false positives, which can lead to wasted resources and reputational damage. Furthermore, the sensitivity of financial transaction data necessitates a robust and compliant approach to analysis and reporting. Correct approach analysis. The correct approach involves leveraging AWS services to build a robust anomaly detection system that incorporates domain expertise and adheres to regulatory requirements. Specifically, using Amazon TimeStream for storing time series data, Amazon SageMaker for building and deploying machine learning models, e.g., ARMA, Profit, or LSTM for forecasting and anomaly detection, and AWS Lambda for real-time processing and alerting. This approach is best professional practice because it is scalable, cost-effective, and allows for sophisticated pattern recognition. Critically, it aligns with the principles of data governance and security mandated by U.S. financial regulations. By implementing anomaly detection models that are trained on historical data and continuously monitored, the system can identify deviations from expected patterns. The use of SageMaker ensures that models are developed and deployed in a controlled environment, and alerts can be routed to appropriate personnel for investigation. This proactive stance is essential for compliance with regulations like the Bank Secrecy Act, BSA, and the USA Patriot Act, which require financial institutions to have systems in place to detect and report suspicious activities. The focus on identifying statistically significant deviations, rather than arbitrary thresholds, minimizes false positives and ensures that investigations are targeted and efficient. Incorrect approaches analysis. One incorrect approach is to solely rely on simple threshold-based alerting without considering the temporal nature of the data. This fails to account for seasonality, trends, or other legitimate variations in transaction volumes or values, leading to a high rate of false positives. Ethically and regulatorily, this is problematic as it can overwhelm investigation teams with non-suspicious alerts, diverting resources from genuine threats and potentially leading to missed fraudulent activities. It also fails to demonstrate a sophisticated understanding of data analysis required by financial regulators. Another incorrect approach is to implement anomaly detection without considering data privacy and security. Storing sensitive financial transaction data without proper encryption, access controls, or anonymization where appropriate violates regulations such as the Gramm-Leach-Bliley Act, GLBA, and potentially state-level data privacy laws. This approach poses significant ethical risks, including data breaches and misuse of customer information, and carry severe legal and financial penalties. A third incorrect approach is to use off-the-shelf anomaly detection tools without customization or validation against specific business context and regulatory requirements. While these tools might offer basic functionality, they often lack the nuance required to accurately identify financial anomalies. This can lead to missed fraud or the flagging of legitimate business activities as suspicious, both of which have regulatory implications. It demonstrates a lack of due diligence in selecting and implementing analytical solutions, which is a failure in professional responsibility. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes a risk-based approach, aligning analytical capabilities with regulatory obligations and business objectives. This involves 1. Understanding the regulatory landscape. Identify all applicable U.S. financial regulations, e.g., BSA, USA Patriot Act, GLBA, and their implications for data analysis and anomaly detection. 2. Defining clear objectives. Establish what constitutes an anomaly in the context of the business and what actions should be taken upon detection. 3. Selecting appropriate tools and technologies. Choose AWS services that are scalable, secure, and capable of handling time series data and advanced analytics while ensuring compliance. 4. Developing and validating models. Build anomaly detection models that are statistically sound, interpretable, and validated against business context. 5. Implementing robust monitoring and alerting. Establish clear protocols for alert handling, investigation, and escalation. 6. Ensuring data governance and security. Implement strict access controls, encryption, and data privacy measures throughout the data lifecycle. 7. Continuous improvement. Regularly review and refine the anomaly detection system based on performance, feedback, and evolving regulatory requirements. Question 13. Benchmark analysis indicates that a financial services firm is migrating its critical transaction processing to AWS, utilizing Amazon SQS to decouple microservices. Given the sensitive nature of the data and the stringent regulatory environment in the United States, which of the following SQS configurations best addresses the need for data protection at rest and comprehensive auditability for compliance purposes? Option A. Deploy SQS FIFO queues to ensure message ordering and assume inherent security due to the queue type. Option B. Configure SQS with server-side encryption using AWS KMS and enable SQS access logging. Option C. Implement client-side encryption for all messages before sending them to SQS and rely on application-level logging. Option D. Utilize standard SQS queues without any specific encryption or logging configurations. The correct answer is B. Configure SQS with server-side encryption using AWS KMS and enable SQS access logging. Explanation. Scenario analysis. This scenario presents a professional challenge related to data processing and compliance within the AWS ecosystem, specifically concerning the use of Amazon SQS for decoupling critical financial data streams. The core challenge lies in ensuring that the chosen SQS configuration not only meets performance and reliability requirements, but also adheres to the stringent regulatory framework governing financial data handling in the United States. The need for robust audit trails, data integrity, and controlled access to sensitive information makes the selection of SQS features a critical decision with significant compliance implications. Misconfiguration can lead to data loss, unauthorized access, or an inability to demonstrate compliance during audits, all of which carry severe penalties. Correct approach analysis. The correct approach involves configuring SQS with server-side encryption, SSE, using AWS Key Management Service, KMS, and enabling SQS access logging. This strategy represents best professional practice because it directly addresses key regulatory requirements for financial data in the U.S. SSE with KMS ensures that data at rest within SQS queues is encrypted, protecting it from unauthorized access even in the event of a physical breach of AWS infrastructure. This aligns with principles of data confidentiality and integrity mandated by regulations like the Gramm-Leach-Bliley Act, GLBA, and potentially aspects of the Payment Card Industry Data Security Standard, PCI DSS, if cardholder data is involved. Enabling SQS access logging provides an immutable audit trail of who accessed the queue, when, and from where. This is crucial for demonstrating accountability, detecting suspicious activity, and fulfilling audit requirements under various financial regulations. The combination of encryption and logging provides a layered security and compliance posture. Incorrect approach is analysis. One incorrect approach is to solely rely on standard SQSQ configurations without any encryption or logging. This is professionally unacceptable because it fails to meet the fundamental data protection and auditability requirements for sensitive financial data. Regulations like GLBA explicitly mandate measures to protect customer information, and unencrypted data at rest is a clear violation. The absence of access logs makes it impossible to conduct effective security investigations or satisfy audit demands, leading to potential regulatory fines and reputational damage. Another incorrect approach is to implement client-side encryption before sending messages to SQS, while neglecting server-side encryption and access logging. While client-side encryption adds a layer of security, it shifts the burden of key management entirely to the application. If not managed meticulously, it can introduce vulnerabilities. More importantly, it does not address the data at rest within SQS itself if the messages are stored unencrypted by SQS. Furthermore, the lack of SQS access logging means that actions taken directly on the SQSQE by AWS administrators or other services with direct SQS permissions would not be recorded, leaving a gap in the audit trail. This approach is insufficient for comprehensive compliance. A third incorrect approach is to enable SQS FIFO queues for improved message ordering but overlook encryption and logging. While FIFO queues offer enhanced ordering guarantees, which can be beneficial for certain financial transaction processing, they do not inherently provide data security or auditability. The primary benefit of FIFO is ordering, not compliance with data protection mandates. Without encryption, the data is vulnerable at rest, and without logging, the necessary audit trails are absent, rendering this configuration non-compliant for sensitive financial data. Professional reasoning. Professionals should adopt a risk-based approach, prioritizing compliance and security from the outset. When dealing with sensitive data, especially in regulated industries like finance, the default assumption should be that robust security controls are mandatory. The decision-making process should involve 1. Identifying applicable regulations and compliance requirements for the specific data being processed. 2. Understanding the capabilities of AWS services in relation to these requirements. 3. Designing a solution that incorporates security and auditability features as core components, not as afterthoughts. 4. Regularly reviewing and updating configurations to align with evolving threats and regulatory landscapes. In this context, the professional must recognize that SQS, while a powerful decoupling service, requires specific configurations to meet U.S. financial data regulations. The choice between standard and FIFO queues is a functional decision, but the security and logging aspects are compliance imperatives. Question 14. Analysis of how to best establish and maintain comprehensive data lineage improvements for sensitive financial data processed within AWS, ensuring compliance with U.S. financial regulations, requires a strategic approach to data governance and auditing. Which of the following strategies most effectively addresses these requirements? Option A. Implementing a combination of AWS Glue Data Catalog for metadata, AWS Lake Formation for access control, and AWS Cloud Trail for API activity logging to create an integrated lineage improvements framework. Option B. Empowering individual data engineering teams to implement their own bespoke lineage tracking solutions using a variety of third-party tools and custom code, with minimal central oversight. Option C. Focusing exclusively on capturing detailed logs of all data access events across AWS services, assuming this fully satisfies provenance requirements. Option D. Relying on manual documentation of data flows and transformations, supplemented by ad hoc scripts to capture basic access logs, with periodic reviews by data stewards. The correct answer is A. Implementing a combination of AWS Glue Data Catalog for metadata, AWS Lake Formation for access control, and AWS Cloud Trail for API activity logging to create an integrated lineage improvements framework. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing the need for robust data lineage improvements for regulatory compliance and auditability with the practicalities of implementing and maintaining such systems within a cloud environment like AWS. Organizations often face pressure to demonstrate compliance with various data governance mandates, which necessitates a clear understanding of where data originates, how it transforms, and who accesses it. The complexity arises from the dynamic nature of cloud services, the potential for multiple data pipelines, and the need to integrate lineage tracking across disparate AWS services. Making the wrong choice can lead to significant compliance risks, audit failures, and an inability to respond effectively to data-related incidents or inquiries. Correct approach analysis. The correct approach represents best professional practice because it directly addresses the core requirements of data lineage and provenance by leveraging AWS native services designed for this purpose. Specifically, using AWS Glue Data Catalog for metadata management, AWS Lake Formation for access control and governance, and Cloud Trail for logging API calls provides a comprehensive, integrated solution. This approach ensures that metadata about data assets, their schemas, and their relationships is captured and maintained. Lake Formation enforces granular access policies, contributing to provenance by tracking who can access what data. Cloud Trail provides an immutable audit trail of all API activities, which is crucial for understanding data access and modification events, thereby establishing provenance. This integrated, service-oriented strategy aligns with AWS best practices for data governance and security, offering a scalable and manageable solution that meets regulatory expectations for data traceability and accountability. Incorrect approach is analysis. An approach that relies solely on manual documentation and ad hoc scripting for lineage tracking is professionally unacceptable due to inherent scalability and reliability issues. Manual documentation is prone to human error, becomes outdated quickly in dynamic cloud environments, and is difficult to audit comprehensively. This failure to automate and integrate lineage tracking directly contravenes regulatory expectations for auditable and verifiable data governance. An approach that focuses only on logging data access events without capturing transformation logic or metadata is also professionally deficient. While logging access is a component of provenance, it does not provide a complete picture of data lineage. Regulations often require understanding the asterisk how asterisk and asterisk why asterisk of data changes, not just who accessed it. Without tracking transformations, it's impossible to fully reconstruct data history or identify the root cause of data quality issues, leading to potential compliance gaps. An approach that delegates all data lineage responsibilities to individual data engineers without a centralized governance framework is professionally unsound. This leads to inconsistent implementation, lack of standardization, and an inability to provide a unified view of data lineage across the organization. It creates significant audit risks and makes it difficult to enforce consistent data governance policies, which are often mandated by regulatory bodies. Professional reasoning. Professionals should approach data lineage and provenance by first understanding the specific regulatory requirements applicable to their industry and jurisdiction. This involves identifying what level of detail is needed for audit trails, data transformation tracking, and access control. Next, they should evaluate AWS services that can automate and integrate these capabilities. A layered approach, combining metadata management, access governance, and comprehensive logging, is generally most effective. Prioritizing solutions that provide an auditable and immutable record of data activities is paramount. When evaluating options, consider the ease of integration with existing data pipelines, the scalability of the solution, and its ability to provide a consolidated view of lineage. The decision-making process should always prioritize compliance, security, and operational efficiency, ensuring that the chosen solution can withstand scrutiny from auditors and regulators. Question 15. The control framework reveals a critical risk in the data analytics pipeline responsible for processing sensitive customer financial data. The pipeline experiences intermittent failures during data ingestion, leading to potential data loss and inconsistencies. The primary concern is to implement an effective error handling and recovery strategy that aligns with U.S. regulatory requirements for data protection and financial reporting integrity. Which of the following approaches best addresses this risk? Option A. Rely solely on periodic data backups to recover from any data loss without implementing specific error handling during the ingestion process. Option B. Disable detailed error logging for non-critical data streams to reduce system overhead and improve ingestion speed. Option C. Focus on immediate notification of all errors to the operations team, assuming they can manually address each issue as it arises. Option D. Implement automated retry mechanisms for transient errors. Utilize a dead letter queue for persistent failures. Establish real-time monitoring and alerting for anomalies, and define clear operational runbooks for manual investigation and recovery. The correct answer is D. Implement automated retry mechanisms for transient errors. Utilize a dead letter queue for persistent failures. Establish real-time monitoring and alerting for anomalies, and define clear operational runbooks for manual investigation and recovery. Explanation. The control framework reveals a critical risk associated with a data analytics pipeline that processes sensitive customer financial data. The challenge lies in ensuring robust error handling and recovery mechanisms are in place to prevent data loss or corruption, which could lead to regulatory noncompliance and significant financial and reputational damage. The scenario demands a proactive approach to risk assessment, focusing on the potential impact of failures and the effectiveness of mitigation strategies. The correct approach represents best professional practice because it prioritizes a comprehensive, layered strategy for error handling and recovery. This involves not only implementing technical safeguards like automated retries and dead letter queues, but also establishing clear operational procedures for monitoring, alerting, and manual intervention. This aligns with the principles of data integrity and availability, which are fundamental to regulatory compliance in financial data processing. Specifically, for the U.S. jurisdiction, this approach supports adherence to regulations like the Gramm-Leach-Bliley Act, GLBA, and the Sarbanes-Oxley Act, SOX, by demonstrating due diligence in protecting sensitive data and ensuring the reliability of financial reporting systems. It also reflects best practices in cloud security and data governance, emphasizing resilience and minimizing downtime. An incorrect approach that focuses solely on immediate error notification without a defined recovery plan is professionally unacceptable. This failure constitutes a significant regulatory risk under GLBA, which mandates safeguards to protect customer information. Without a recovery plan, data loss or corruption could occur, leading to potential breaches and violations of data protection requirements. Such an approach demonstrates a lack of preparedness and an insufficient understanding of the potential consequences of system failures. Another incorrect approach that relies exclusively on manual intervention for all error scenarios is also professionally deficient. While manual intervention can be part of a recovery strategy, making it the sole mechanism is inefficient and introduces unacceptable delays, especially in high-volume data processing. This can lead to prolonged periods of data unavailability or inconsistency, violating the principle of data integrity and potentially contravening SOX requirements for accurate and timely financial data. Furthermore, it increases the risk of human error during the recovery process. A third incorrect approach that involves disabling error logging to reduce system overhead is critically flawed and ethically unsound. This directly undermines the ability to diagnose and recover from failures, creating a blind spot in the system's operational visibility. It is a direct contravention of regulatory expectations for auditability and accountability, making it impossible to investigate the root cause of errors or demonstrate compliance. This approach prioritizes short-term performance gains over long-term data integrity and security. The professional decision-making process for similar situations should involve a structured risk assessment framework. This begins with identifying potential failure points in the data analytics pipeline. For each identified risk, the potential impact, e.g., data loss, compliance violation, service disruption, must be evaluated. Subsequently, appropriate mitigation strategies, including technical controls and operational procedures, should be designed and implemented. Regular testing and review of these mechanisms are crucial to ensure their effectiveness and to adapt to evolving threats and regulatory landscapes. This proactive and systematic approach ensures that data is processed reliably and securely, meeting both business objectives and regulatory mandates. Question 16. Compliance review shows that a financial services firm is planning to deploy a new natural language processing (NLP) model to analyze customer feedback for sentiment and topic extraction. The model will process a large volume of unstructured text data, which may include personally identifiable information (PI) and sensitive financial details. Which approach best ensures compliance with U.S. federal data privacy and security regulations? Option A. Deploy the NLP model immediately to gain early insights and address any potential data privacy concerns that arise after the initial deployment based on user feedback or reported incidents. Option B. Prioritize achieving the highest possible model accuracy and performance metrics, as this will lead to better business insights and implicitly protect customer data through effective analysis. Option C. Assume that all data processed by the NLP model is anonymized by default and focus solely on the technical implementation of the NLP solution without a detailed review of the data sources or their inherent sensitivity. Option D. Conduct a comprehensive data privacy and security impact assessment specifically for the NLP model, evaluating its potential to expose or misuse sensitive data throughout its lifecycle, and implement appropriate data minimization and anonymization techniques. The correct answer is D. Conduct a comprehensive data privacy and security impact assessment specifically for the NLP model, evaluating its potential to expose or misuse sensitive data throughout its lifecycle, and implement appropriate data minimization and anonymization techniques. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent sensitivity of customer data processed by NLP models. Organizations must balance the benefits of advanced analytics with the stringent requirements of data privacy regulations. The challenge lies in identifying and mitigating risks associated with the use of NLP, particularly when dealing with personally identifiable information, PI, or other regulated data. Careful judgment is required to ensure that the chosen NLP approach not only achieves business objectives, but also adheres strictly to the specified regulatory framework, which in this context is U.S. federal law governing data privacy and security. Correct approach analysis. The correct approach involves a comprehensive impact assessment that specifically evaluates the NLP model's potential to expose or misuse sensitive data. This assessment must consider the entire data lifecycle, from ingestion to model training, inference, and output. It should identify data minimization opportunities, assess the effectiveness of anonymization or pseudonymization techniques, and evaluate the security controls surrounding the model and its data. This aligns with the principles of privacy by design and by default, mandated by regulations like the Health Insurance Portability and Accountability Act, HIPAA, for health information, and the Children's Online Privacy Protection Act, COPPA, for children's data, and general principles of data protection under the Federal Trade Commission, FTC Act. A thorough impact assessment ensures that the organization proactively addresses potential privacy and security risks before deployment, thereby demonstrating due diligence and compliance. Incorrect approaches analysis, focusing solely on model accuracy without considering data privacy implications, is a significant regulatory and ethical failure. Regulations like HIPAA and COPPA and general FTC guidelines regarding unfair or deceptive practices mandate that organizations protect sensitive data. Ignoring the potential for PII leakage or misuse during NLP processing, even if the model is highly accurate, can lead to substantial fines, reputational damage, and loss of customer trust. Implementing NLP without a clear understanding of the data sources and their sensitivity is another failure. If the data used for training or inference contains PII, and this is not adequately identified and protected, the organization risks violating data privacy laws. This lack of understanding can lead to unintentional noncompliance, as the organization may not be aware of the specific protections required for the data it is handling. Relying solely on third-party vendor assurances without independent verification of their data handling practices is also problematic. While vendors may claim compliance, the ultimate responsibility for protecting customer data rests with the organization deploying the NLP solution. A failure to conduct due diligence on vendor practices can result in the organization being held liable for breaches or misuse of data, even if the fault lies with the vendor. This demonstrates a lack of proactive risk management and adherence to the principle of accountability. Professional reasoning. Professionals should adopt a risk-based approach to NLP implementation. This involves 1. Data inventory and classification. Understand what data is being used, its sensitivity, and applicable regulations. 2. Risk assessment. Identify potential privacy and security risks associated with NLP processing. 3. Mitigation strategies. Implement technical and organizational measures to reduce identified risks, e.g., anonymization, access controls, encryption. 4. Continuous monitoring. Regularly review and update assessments and controls as models and data evolve. 5. Documentation. Maintain thorough records of assessments, decisions, and mitigation efforts for audit and compliance purposes. This systematic process ensures that data privacy and security are integrated into the NLP development and deployment lifecycle, fostering responsible innovation and maintaining regulatory compliance. Question 17. Research into the development of a customer segmentation model for targeted marketing campaigns reveals that historical customer data, while appearing statistically sound, may reflect past discriminatory practices in service offerings. The data science team is tasked with ensuring the model is fair and does not perpetuate or amplify these biases. Which of the following implementation strategies best aligns with responsible data analytics practices and regulatory expectations for preventing discriminatory outcomes? Option A. Implement a rigorous bias detection and mitigation framework throughout the model development lifecycle, including pre-processing data transformations, in-processing model adjustments, and post-processing fairness constraints, while documenting all decisions and their rationale. Option B. Focus primarily on optimizing the model for overall predictive accuracy, assuming that a highly accurate model will inherently be fair, and that any perceived bias is a result of user interpretation. Option C. Develop the model and deploy it to business units, with the expectation that downstream users will be responsible for identifying and addressing any fairness issues that arise in their specific applications of the model. Option D. Proceed with model development using the existing data without explicit bias detection or mitigation, as the data has passed standard statistical validation checks and appears clean on the surface. The correct answer is A. Implement a rigorous bias detection and mitigation framework throughout the model development lifecycle, including pre-processing data transformations, in-processing model adjustments, and post-processing fairness constraints, while documenting all decisions and their rationale. Explanation. This scenario presents a common implementation challenge in data analytics, ensuring fairness and mitigating bias in machine learning models, particularly when those models are used for decision-making that impacts individuals. The challenge lies in the inherent complexity of identifying and addressing bias, which can be subtle and deeply embedded in historical data. Professionals must navigate the tension between achieving model performance and upholding ethical principles and regulatory compliance, especially concerning data privacy and non-discrimination. The correct approach represents best professional practice because it proactively addresses potential bias at multiple stages of the data lifecycle. By establishing clear ethical guidelines, performing thorough bias assessments using appropriate metrics, and implementing bias mitigation techniques during model development and deployment, organizations demonstrate a commitment to fairness and responsible AI. This aligns with the spirit of regulations that aim to prevent discriminatory outcomes, even if specific bias metrics are not explicitly mandated by law. It prioritizes transparency and accountability, which are foundational to ethical data practices. An incorrect approach that relies solely on achieving high overall accuracy fails to acknowledge that a model can be highly accurate on average, while still exhibiting significant bias against specific demographic groups. This overlooks the potential for disparate impact, which is a key concern in many regulatory frameworks designed to prevent discrimination. Another incorrect approach that ignores bias detection and mitigation because the data appears clean is a critical failure. Bias is not always evident in raw data and can emerge from the way data is collected, processed, or from historical societal inequities reflected in the data. Ignoring this possibility leads to the perpetuation and amplification of existing biases. A further incorrect approach that defers bias responsibility to downstream users without implementing internal checks is also professionally unacceptable. Organizations developing and deploying data analytics solutions have a primary responsibility to ensure their systems are fair and compliant. Shifting this burden without due diligence is a dereliction of ethical and potentially legal duty. The professional decision-making process for similar situations should involve a multi-stakeholder approach, starting with defining clear ethical objectives and understanding the potential societal impact of the data analytics solution. This should be followed by a rigorous data governance framework that includes bias assessment tools and mitigation strategies. Continuous monitoring and auditing of deployed models for fairness are essential, Professionals should consult relevant ethical AI frameworks and legal guidance to inform their decisions, prioritizing fairness and equity alongside performance. Question 18. Benchmark analysis indicates that Amazon MWDAG parsing is consistently exceeding acceptable latency thresholds, leading to delays in task scheduling and execution. The Airflow web server logs show high CPU utilization during peak hours, while worker utilization remains moderate. Which approach would most effectively address this performance bottleneck and improve overall pipeline throughput? Option A. Scale up the Airflow web server instance type and increase the number of Airflow workers. Option B. Increase the number of Airflow workers and adjust the DAG parsing interval to a shorter duration. Option C. Focus on optimizing individual task code for faster execution and increase the DAG parsing interval. Option D. Increase the resources allocated to the Airflow scheduler and reduce the DAG parsing interval. The correct answer is B. Increase the number of Airflow workers and adjust the DAG parsing interval to a shorter duration. Explanation. This scenario presents a common challenge in cloud-native data orchestration, optimizing the performance and cost efficiency of a managed Apache Airflow environment, Amazon MWA, without compromising data integrity or compliance. The professional challenge lies in balancing resource utilization, execution speed, and the potential for cascading failures, all while adhering to the implicit regulatory expectation of reliable and auditable data processing. Careful judgment is required to select an optimization strategy that is both technically sound and aligns with best practices for operational excellence and data governance. The correct approach represents best professional practice because it directly addresses the identified bottleneck, DAG parsing, by scaling the Airflow web server, which is responsible for parsing DAGs and serving the UI. This targeted scaling ensures that the core Airflow components can handle the increased workload without impacting the execution of tasks themselves. Furthermore, by increasing the worker count, it directly addresses the backlog of tasks waiting to be executed, improving overall pipeline throughput. This strategy is aligned with the principle of least privilege and efficient resource allocation, ensuring that only the necessary components are scaled to meet demand, which is a key tenet of cost optimization and operational efficiency, implicitly supporting regulatory requirements for responsible resource management. An incorrect approach that focuses solely on increasing the worker count without addressing the DAG parsing bottleneck would lead to a situation where workers are idle, waiting for DAGs to be parsed and tasks to be scheduled. This is inefficient and does not resolve the root cause of the delay. From a regulatory perspective, this could be seen as a failure in operational diligence, as resources are not being utilized effectively, potentially leading to increased costs without commensurate performance gains. Another incorrect approach that involves increasing the scheduler's resources without considering the web server's role in DAG parsing would similarly fail to address the primary bottleneck. While schedulers are critical for task execution, the web server is the component that initially processes and makes DAGs available. Over-provisioning the scheduler without resolving the parsing issue is a misallocation of resources. Ethically and professionally, this represents a lack of thorough root cause analysis, leading to suboptimal solutions and wasted expenditure, which can indirectly impact compliance by diverting resources from other critical areas. A further incorrect approach that involves reducing the DAG parsing interval without a corresponding increase in web server resources would exacerbate the problem. This would lead to more frequent parsing attempts by an already overloaded web server, increasing latency, and potentially causing the web server to become unresponsive. This directly undermines the reliability of the data pipelines, which is a fundamental expectation for any regulated data processing environment. It demonstrates a failure to understand the interdependencies of Airflow components and a disregard for the stability of the system. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the bottleneck. Utilize monitoring tools and logs to pinpoint the specific component or process causing performance degradation. In this case, the benchmark analysis clearly indicates DAG parsing as the bottleneck. 2. Understand component responsibilities. Comprehend the role of each Airflow component, web server, scheduler, worker, and how they interact. 3. Targeted scaling. Apply scaling strategies that directly address the identified bottleneck. Scaling the web server for parsing and workers for execution is a direct and effective solution. 4. Iterative testing and monitoring. Implement changes incrementally and monitor their impact. Continuously refine the configuration based on observed performance metrics. 5. Cost-benefit analysis. Evaluate the cost implications of any scaling decision against the expected performance improvements and business value. 6. Compliance alignment. Ensure that all optimization efforts maintain data integrity, auditability, and operational reliability, which are implicit regulatory requirements for data processing. Question 19. The monitoring system demonstrates a continuous stream of operational metrics from various distributed services. The business requires near real-time detection of anomalies within this stream to trigger immediate alerts for potential system failures or performance degradations. The data volume is substantial and fluctuates, and the analysis involves complex event processing to identify patterns indicative of issues. Which AWS service is most appropriate for ingesting, processing, and analyzing this streaming data for immediate anomaly detection and alerting? Option A. Amazon Kinesis Data Analytics for Apache Flink. Option B. Amazon Redshift for direct ingestion and querying of streaming data. Option C. Amazon EMR with a Spark job for batch processing. Option D. AWS Glue for ETL and subsequent querying on S3. Correct answer is A. Amazon Kinesis Data Analytics for Apache Flink. Explanation. Scenario analysis. This scenario presents a common challenge in data analytics, selecting the most appropriate AWS service for a specific data processing and analysis task, balancing performance, cost, and operational overhead. The challenge lies in understanding the nuances of each service's capabilities and limitation, particularly concerning real-time versus batch processing, data volume, and the complexity of analytical queries. A misstep can lead to inefficient resource utilization, increased costs, delayed insights, or an inability to meet business requirements, all of which have direct implications for operational efficiency and potentially regulatory compliance if data timeliness is critical. Correct approach analysis. Choosing Amazon Kinesis Data Analytics for Apache Flink is the best professional practice in this scenario. This service is specifically designed for real-time processing of streaming data, allowing for complex event processing and continuous analytics. Its ability to ingest data from sources like Kinesis data streams and Apache Kafka, perform stateful computations, and output results to various destinations, e.g. S3, other Kinesis streams, Lambda, directly addresses the requirement for near real-time anomaly detection and alerting. This aligns with best practices for operational monitoring, where timely identification of issues is paramount for mitigating potential business impact. The service's managed nature also reduces operational burden compared to self-managed solutions. Incorrect approaches analysis. Using Amazon EMR with a Spark job for batch processing would be a regulatory and ethical failure if the requirement is for real-time anomaly detection. EMR is optimized for large-scale batch processing and complex analytical workloads, but it introduces latency. Relying on batch processing for real-time anomaly detection means that critical issues might not be identified until hours or even days after they occur, potentially violating service-level agreements, SLAs, or internal policies that mandate prompt issue resolution. This delay could lead to significant financial losses or reputational damage, which are implicitly covered by operational risk management frameworks. Selecting AWS Glue for ETL and then running queries on the processed data in S3 would also be a failure in this context. AWS Glue is primarily an ETL service, excellent for transforming and preparing data for analytics, but it is not designed for continuous, real-time stream processing. While Glue can process data in batches or on demand, it would introduce significant latency between data ingestion and anomaly detection, rendering it unsuitable for the stated requirement. This approach would fail to provide timely insights, potentially leading to prolonged periods of undetected anomalies, which is a failure in proactive risk management. Opting for Amazon Redshift for direct ingestion and querying of streaming data would be inefficient and potentially costly. Redshift is a data warehouse service optimized for complex analytical queries on large datasets, but it is not inherently designed for high-throughput, low-latency stream ingestion and real-time processing. While it can be used in conjunction with streaming services, using it as the primary engine for continuous anomaly detection on raw streaming data would likely lead to performance bottlenecks and higher costs due to the nature of its architecture and query processing. This represents a failure in cost optimization and efficient resource utilization, which are key professional responsibilities. Professional reasoning. Professionals should employ a decision-making framework that begins with a clear understanding of the business requirements, specifically focusing on data velocity, volume, variety, and the required latency for insights. This involves mapping these requirements to the core strengths of available AWS services. For real-time processing and anomaly detection on streaming data, services like Kinesis Data Analytics for Apache Flink are purpose-built. For batch processing and complex transformations, EMR or Glue are more appropriate. For analytical querying on structured data, Redshift is a strong contender. A critical step is to evaluate the operational overhead, scalability, and cost-effectiveness of each potential solution against the defined requirements. This systematic approach ensures that the chosen service not only meets the technical needs, but also aligns with broader business objectives and operational best practices. Question 20. Which approach would be most appropriate for securely integrating sensitive financial data from an on-premises system into an AWS data lake for analytics, ensuring compliance with data protection best practices? Option A. Ingest data into Amazon RDS first, then export it to S3 for analytics, assuming RDS provides sufficient inherent security for the sensitive financial data during the initial ingestion phase. Option B. Develop a custom script to transfer data to Amazon S3, relying solely on the default network security of the on-premises environment in AWS, without explicit encryption configurations for data in transit or at rest. Option C. Utilize AWS Glue to extract, transform, and load ETL the data, configuring encryption for data at rest within S3 and ensuring SSL/TLS encryption for data in transit, managed through IAM roles for access control. Option D. Directly transfer raw financial data files from the on-premises system to an Amazon S3 bucket using a simple file transfer protocol, without any intermediate encryption or access control configurations. The correct answer is C. Utilize AWS Glue to extract, transform, and load ETL, the data, configuring encryption for data at rest within S3, and ensuring SSL/TLS encryption for data in transit, managed through IAM roles for access control. Explanation. This scenario presents a professional challenge due to the need to balance data integration efficiency with robust security and compliance requirements inherent in handling sensitive financial data within the AWS ecosystem. The core difficulty lies in selecting an integration strategy that minimizes data exposure during transit and at rest, while also ensuring auditability and adherence to potential regulatory mandates for data processing and storage, even within a cloud environment. Careful judgment is required to avoid introducing vulnerabilities or violating data governance policies. The correct approach represents best professional practice because it prioritizes security and compliance by leveraging AWS services designed for secure data ingestion and transformation. Using AWS Glue with its built-in encryption, capabilities for data at rest, and SSL/TLS for data in transit, combined with IAM roles for fine-grained access control, directly addresses the need for secure handling of sensitive financial data. This strategy aligns with the principle of least privilege and ensures that data is protected throughout the integration pipeline, which is a fundamental requirement for maintaining trust and regulatory compliance in data analytics. An incorrect approach that involves directly transferring raw data from the on-premises system to Amazon S3 without intermediate encryption or access controls is professionally unacceptable. This failure would violate the principle of data protection by exposing sensitive financial information in a less secure state, potentially leading to unauthorized access and breaches. Furthermore, it bypasses opportunities to implement necessary data masking or anonymization techniques required by certain financial regulations, creating significant regulatory and ethical failures. Another incorrect approach, such as using a custom script to transfer data without explicit encryption configurations, introduces an unacceptable level of risk. While seemingly efficient, the lack of guaranteed encryption in transit and at rest leaves the data vulnerable. This oversight could lead to non-compliance with data privacy laws and industry-specific regulations that mandate secure data handling, representing a critical ethical lapse in professional responsibility. Professionals should employ a decision-making framework that begins with a thorough understanding of the data's sensitivity and applicable regulatory requirements. This should be followed by an evaluation of AWS services based on their security features, compliance certifications, and integration capabilities. Prioritizing solutions that offer end-to-end encryption, robust access management, and audit logging is paramount. The framework should also include a risk assessment for each potential integration method, focusing on potential data exposure points and compliance gaps.